We are living through a convergence of extreme planetary pressures. Global power is fracturing into a multipolar order. We are in the midst of a sixth mass extinction. And at the local level, the basic social fabric holding communities together is rapidly fraying. To understand why this is happening, we have to look at how human civilizations operate under stress. The anthropologist Joseph Tainter observed that societies naturally try to solve their internal problems by adding layers of complexity, more rules, more technology, and more bureaucratic institutions. This chart visualizes what Tainter identified as a structural flaw. As you plot societal cost on the horizontal axis against the benefits returned on the vertical axis, you see a steady rise that eventually flattens out. This is the law of diminishing returns. Adding more bureaucracy and tools eventually stops fixing problems and begins pushing the system into a zone of decline. At this exact inflection point, the dynamic flips. The sheer weight and maintenance cost of that massive, tangled web of complexity becomes the very mechanism that breaks the system apart. Calculated from the history of complex systems, societal collapse is a realistic mathematical threat rather than a trope of science fiction. It is a vulnerability embedded in the very way our modern world operates. The standard response to this math is to double down on what we already do. We assume we can maintain infinite growth and dodge these structural limits simply by inventing newer, better technology. You hear this in pitches to launch our massive internet data centers into space, or in Silicon Valley initiatives aiming to classify aging as a medically curable disease. The theoretical physicist Michio Kaku has mapped out which science fiction concepts might eventually align with the laws of physics. However, analyzing these possibilities requires deep intellectual humility, as theoretical physics is quite different from immediate, scalable engineering. When we try to brute force our way out of structural problems with unproven technology, we often just add new layers of social friction that we don't know how to manage. Pinning our survival entirely on techno-optimism blinds us to immediate side effects. It deepens social inequality and drives emotional polarization by prioritizing high-tech solutions for the few, while the underlying social systems for the many continue to deteriorate. Take the proposal to move global data centers into Earth's orbit to escape our energy and land constraints. A major data center requires about 5 gigawatts of power. Using current semiconductor technology, operating something that massive in the vacuum of space generates an enormous amount of trapped heat that requires heavy dissipation. This compares a standard server rack to the infrastructure required in orbit. To cool a 5 gigawatt facility, the space heat sink would measure 2 kilometers per side. Lifting this structure out of Earth's gravity well translates into exponential payload costs, making the logistics prohibitive. A breakthrough in ultra-low power AI chips could eventually reduce that heat output, but that hardware does not exist at the commercial scale required today. Fixating on energy-intensive, physically improbable orbital structures creates a dangerous illusion. It drains attention and resources away from fixing the highly vulnerable systems we rely on right now on Earth. We see a similar gap with biological limits, specifically the drive to achieve human immortality by classifying aging as a curable disease. The human body is not a machine with easily replaceable parts. Aging and neurodegenerative conditions like dementia operate within a highly unpredictable, complex system where millions of variables interact in ways we still cannot fully map. Medical science has yet to find a reliable cure for dementia. Assuming we can completely eradicate the broader biological process of aging in the near term is a severe miscalculation of our current scientific reach. The ecologist C.S. Halling mapped how complex systems actually behave. He proved that whether you are looking at a forest ecosystem or a human society, nothing in nature sustains endless upward growth. This diagram outlines Halling's adaptive cycle. Every complex system moves through 4 strict stages: growth, accumulation, collapse, and reorganization. Within this cycle, collapse functions as a necessary transition that clears the path and provides the materials for systemic reorganization. Because our civilization operates as a complex system, trying to artificially force permanent growth is biologically and mathematically impossible. True resilience requires us to accept and prepare for these inevitable cycles of breaking down and rebuilding. The traditional way we plan for tomorrow relies on a deterministic model called prediction. This is the assumption that if we gather enough data on the causes, we can perfectly calculate one specific, fixed future outcome. This shows the difference between prediction and foresight. Prediction draws a rigid line forward, while foresight maps a branching tree of possibilities. When an unexpected obstacle appears, the rigid prediction model shatters. The foresight model survives by adapting and navigating around the disruption. This framework must filter down into our daily lives, taking root in the local communities, neighborhoods, and alleyways where our actual social fabric is built. To survive the limits of our own complexity, both leaders and citizens must abandon the illusion of infinite growth. We have to actively employ futures literacy to navigate the hard realities of the world we've built and construct a resilient society on the other side of the curve.